Okay, hello everybody and welcome to Friday Focus. We're going to be looking at arithmetic on this channel. Today's lesson we're going to start with some factor pairs. I thought this would be a really good lesson to start on because it's quite simple, it's using our multiplication skills, and hopefully it will get you into the habit of how we're going to be learning using these videos. So our learning objective is to understand and use factor pairs, and our milestones, they're the landmarks that we want to reach in our learning, are: can I develop my understanding of factor pairs? Can I record factors systematically? That word systematically means step by step. Can you do it clearly? Can you show evidence of how you're doing it? So we're going to work our way through the different challenges. If you pause the video, and then you will get the answer afterwards. So I'll tell you when to pause. For this video, it would be great if you could have a pencil, some paper, a ruler. You might want to use a whiteboard. If you have one at home, that would be fantastic. So the first question, if we look here in the left-hand side, challenge 1. What factor pairs for 12 do these arrays show? So an array is a way of actually showing a multiplication. We can see by looking at those different coloured circles how each object is multiplied and in a group. So if you look at the red circles to begin with, how many are there and how big is that group? So hopefully you can see that there are 12 and there's only one group. So if we were to write that as a multiplication, it would be either 1 times 12 equals 12, or 12 times 1 equals 12, depending how you look at the calculation. So that means it's commutative. Doesn't matter which order the 1 is in, which order the 12 is in, you will get the same product, which is 12. Okay, so now if you pause the video and have a go for the blue circles and the green circles. So hopefully for the blue circles, you can see here, going this way, 1, 2, 3, 4, 5, 6. How many groups? 2 groups. 6 times 2 equals 12. You may have looked at it this way. 2, how many groups? 1, 2, 3, 4, 5, 6. 2 times 6 equals 12. So you can see the commutative again, doesn't matter what order it is in. Okay, everyone, so moving on to the final one here, the green group this way. 3, how many times? 1, 2, 3, 4. 3 times 4. Now going the opposite way. You have 4, 3 times. Lovely. Question number 2. Don't feel like you have to draw this entire rainbow at home. What I would do is just put the answers in the box. So write them down. Question 2. Complete these factor rainbows. This rainbow is for 28. So if we look here, 1 is being multiplied by a mystery number. And what is that answer going to be? Look at the question carefully. 1 times something equals, the rainbow is for 28. So what do we multiply 1 by to make 28? What do you multiply 14 by to make 28? What do you multiply 4 by? Pause the video and have a go. 1 by something to equal 28. The way I would look at that is, of course, how many 1s go into 28. So we're thinking of it as a division question this time. We're using the inverse. And it's quite a simple one. There are 28 1s, 28 1s in 28. So 1 times 28 equals 28. When it's the inverse, we are working backwards from the product. 28, we're multiplying it by 1, it equals 28. So whenever you do the inverse operation, start with the answer, work your way backwards, but do the opposite operation. Okay, 14 multiplied by something equals 28. How many 14s go into 28? If you don't know your 14 times table, how can you simplify it? You might ask yourself, well, do I know my 2 times table? Can that help me if you automatically know it's 2? If not, then 14. What are you going to add each time? Going to be adding 14s. So 14, add 14, if we do it as a column addition. 4 add 4, 8, 1 add 1, 2. So we know that it's then 2 lots of 14 that make 28. If you know your times tables, factors are a doddle. How many 4s in 28? So I want to see you doing jottings. 4. Can't write there. Let me just rub these out. Join in with me. We're going to do the 4 times table, everyone, when you're ready. 4, 8, 12, 16, 20, 24, 28. And how many is that? 1, 2, 3, 4, 5, 6, 7. 4 times 7 equals 28. The next rainbow is for 16. Pause the video and have a go. Right, hopefully you should be getting a little bit more confident with this now. So let's have a look. Something times 16 equals 16. A nice easy one to start with. It's 1. 1 times 16 equals 16. Then, what about if it's 2? So how many 2s are in 16? If you know your 8 times table, you should be able to get it really quickly. It's 8. How many 4s in 16? 4. Right, now, can you have a go at drawing your own factor rainbow for 20? Think about what numbers do you know that divide into 20? That's a really good starting point. And I always tell my students at home, start with 1. Every single number can be divided by 1 as long as it's a whole number. So how many 1s? 1 times 20 equals 20. Remember, when you're drawing this rainbow, start with your 1 here, your 20 at the end, and a nice big line on the outside. Then ask yourself, well, what about 2? Will it work for 2? Then 3, 4, so on, and just think about your multiplication. Okay, so pause it there, have a go at drawing your own rainbow. Right, everyone, so hopefully you should have got something like this. So 1 times 20 is 20. 2 times 10 equals 20. 3 does not divide into 20, you cannot multiply it. However, 4, how many times? 5 times. This is getting a little bit messy. So you don't need to then repeat 5 and do 5 times 4, do you? Then we've got 6, no, 7, no, 8, no, 9, no. Okay, and then 10 we've already done. So those are all the factors of 20. Here are your reasoning and problem solving challenges. Tomorrow I will show you the answer, but I want you to have a go at these, and then in the next video we'll go over the answers and really effective ways that you could solve them. So challenge number 2, reasoning and problem solving. Can you find the odd one out? So circle the number which does not have 6 as a factor. Then explain your choice. Challenge number 3 at the bottom, reasoning and problem solving. Ella, the Egyptian, says, the bigger the number, the more factor pairs it will have. Do you agree with Ella? And you need to explain why or why not. have a go at lots of different calculations, and remember, we're trying to work systematically. So start with a large number. Maybe you might want to use a factor rainbow to have a look into all the different factors. And then finally, your extra challenge, true or false. An even number always has an even number of factor pairs, and an odd number always has an odd number of factor pairs. Is this true or false? Prove it. Good luck and do your best. See you all soon. Thank you.